We're going to review how to write triangle congruence proofs today. So we've done proofs before, and you have to have a statement and a reason. So your statement is what you know or can conclude, and your reason is why do you know that? How did you know that? So some examples of reasons you could use in these triangle congruence proofs include that all right angles are congruent, definitions, for example, definition of bisect, midpoint, the definition of an isosceles triangle, some properties, the reflexive property, the transitive property, and some theorems or postulates, vertical angles, alternate interior, same side interior, corresponding angles, base angles. All of those could be potential reasons in triangle congruence proofs. The reason why those could be reasons are because you're looking for congruent sides of triangles and you're looking for congruent angles. So all of these different reasons give us angles or sides. Let's look at this first example. So it's given that BC is congruent to DA and that BC is parallel to AD. And we're trying to prove that triangle ABC is congruent to triangle CDA. So we start out with what they give us. So that's always your first step, is your given. And check your picture and see if that information is labeled in there, which it is. So now we're going to try and find some other parts of the triangles that could be congruent. And they share side AC. So we know that AC is congruent to AC. And that would be the reflexive property. And then if we have parallel lines, those typically give us angles that could be congruent. So in our picture, I could have a set of alternate interior angles. So now I'll write those. So I have angle BCA is congruent to angle DAC. And those would be alternate interior angles. I now have enough information to conclude that those triangles are going to be congruent. So I know that triangle ABC is congruent to triangle CDA, making sure you end your proof with what you want to prove. And I know that because of side, angle, side. Going in order, here's our side, angle, and a side. So side, angle, side. If it helps you to draw the triangles separately, then that could be helpful. Taking them outside of the picture, here's our angle, the other angle, side, and our other side. And that can also show you side, angle, side. So let's look at another example. In this picture, we have these two triangles, and it's given that G is the midpoint of segment EH, FG is congruent to GI, and angles E and H are right angles. So check your picture and see if the information given to you is all there. So FG and GI being congruent is labeled in our pictures, and angles E and H being right angles is labeled. But we know that G is the midpoint of EH. So the definition of midpoint tells us that it splits it into two congruent parts. So that means that EG would be congruent to HG. So now let's start our proof. We're always going to start with writing your given information. So That's our given. And now I can put in what I knew about the midpoint. So I was able to conclude that EG would be congruent to HG, and I know that because the definition of a midpoint. Okay, so looking at my picture, I'm able to now conclude that the triangles would be congruent. So I'm at my last step, so making sure that I end with what the proof wants me to prove. So triangle EFG is congruent to triangle HIG, and it would be because of HL. So looking at these pictures, across from your right angle is your hypotenuse. So there's your other hypotenuse, and then this would be a leg, and up here would be a leg. So that would be why they are congruent by HL. Okay, so another example given to us is that HF is parallel to GK, and that angle F and angle K are right angles, and we're trying to prove that triangle HFG is congruent to triangle GKH. So let's check out the picture and see if everything that's given to us is labeled. So we've got the parallel lines labeled, and we have angles F and K labeled as right angles. So we can start with our given, and that would just be writing everything that was given to you. Okay, so now let's see, what can we conclude from the given information in this picture? Now usually we use parallel lines to find congruent angles. So I have parallel lines. If I draw this transversal in, then I would have alternate interior angles there and there. So here and here will be alternate interior. So angle FHG is congruent to angle KGH, because those would be alternate interior angles. And then we can use the reflexive property to say that HG is congruent to segment HG by the reflexive property. And now I have enough information to say that my triangles are congruent, and they will be congruent by angle, side. So ending with what they want us to end with in the proof, HFG is congruent to triangle GKH by angle, side. So when we're doing triangle congruence proofs, we use something called CPCTC, which stands for corresponding parts of congruent triangles are congruent. So we use this if we're trying to prove that two parts of the triangles are congruent and not just that the triangles are congruent. So for example, if you want to prove that angle A is congruent to angle B, you would want to prove that the triangles are congruent first, and then because those are parts of the triangles, those would be congruent also. So let's look at an example where we would use this. So we're given that AD is congruent to CD, and that B is the midpoint of AC. We're trying to prove that angle A is congruent to angle C. So let's look at our picture. and make sure that we have the given information in there. So AD is congruent to CD. We'll mark that off. B is the midpoint of AC. So B is the midpoint of AC, meaning it splits into two congruent parts. Okay, so that's what's in the given. We know that we want to start with our given. So using this part of our given, where B is the midpoint of AC, then that tells us that segment AB is congruent to segment CB. That's what I have marked off with the double tick marks, and that's by the definition of midpoint. Now they share the middle side in common, so that means that DB is congruent to DB, and that would be by the reflexive property. So now I know that triangle A, B, D is congruent to triangle CB, D, and that would be by side, side, side. So now that we have the triangles being congruent, I can go back and see that I want to prove angle A is congruent to angle C. Since the triangles are congruent, any of the corresponding parts will be congruent. So that means I can end my proof of what I want to prove. Angle A is congruent to angle C, and that would be by C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Okay, so one more example. Given to us is the picture, and we're trying to prove that angle B will be congruent to angle Y. So start with our given. And now let's see if there's anything else that we can conclude based on the picture, since that's all we have. The red dot where C is the center of our circle, which means that from C to Z, C to Y, C to B, and C to A are all a radii in the same circle, which means that those would all be congruent to each other. So we know that CY is congruent to CB. We know that CZ is congruent to CA. And that would be because all radii are congruent. Now I also know that I have vertical angles right here and here. So those would be congruent also. So angle Y, C, Z, congruent to angle B, C, A, because they are vertical angles. And now I have enough information to prove that the triangles are congruent. So triangle YCZ is congruent to triangle BCA, and that will be because of side, angle, side. So SAS. And now that the triangles are congruent, I can get to my last step right here, making sure you end with what you want to prove. So angle B congruent to angle Y, and that will be because of C, P, C, T, C.